Okay, this is about the 5th time I've made this recording, so I hope it works this time. Tonight we're looking at partial fractions. Partial fractions is just another method of integrating that you're going to put in your tool belt. We use partial fractions when we have to integrate a rational expression. The first thing we want to do when we encounter a rational expression is to factor the denominator. So we're going to use our Algebra 2 skills to go ahead and factor this, and we get the integral of 5x minus 3. We're only factoring the denominator. So it's the x minus 3, x plus 1. After we factor the denominator, we're going to write an equivalent expression using two rational terms. And the way we do this is by saying 5x minus 3 is equal to a, where a is some constant, x minus 3, and notice we're using these factors, plus b, x plus 1. Now, to find these values of a and b, the first thing we need to do is multiply by the least common denominator, which would be x minus 3, x plus 1. Notice that when I multiply this entire expression by the least common denominator, this denominator cancels. Okay, so once we multiply by the least common denominator, we see that x minus 3, x plus 1, both of those factors will cancel, and we'll be left with 5x minus 3. When I multiply this term by the common denominator, the x minus 3's will cancel each other out, and we'll be left with a times x plus 1. When I multiply this term by the common denominator, the x plus 1's will cancel out, and then I'm left with plus b times x minus 3. Now, we're going to do something that I call inventive math. It was engineer named Heaviside came up with this method, but I call it inventive math. What we're going to do is we're going to find a value of x that will zero out this term, and then find a value of x that will zero out this term. So of course, looking at it, we can see that if x is equal to -1, then this term zeroes out. So I'm going to replace all the x's with -1. So that gives me -5 minus 3 is equal to, when I evaluate this for -1, that goes to 0, plus b, -1 minus 3 is -4. So that's going to give me -4b. So this -8 is equal to -4b, so b is equal to 2. So now I'm going to see what value will zero out this one, and what value will zero that out is x equals 3. So I'm going to replace all the x's in this expression with 3. So 5 times 3 is 15, minus 3 is 12, and that's going to equal to a times 3 plus 1, which is 4. So I get a is equal to 3. Now, I am not done. I still have to integrate this. But what I can now do is rewrite this with this equivalent expression and get a is 3 over x minus 3 plus b, which is 2 over x plus 1. And as you can probably see by now, that I can now use natural logs to integrate this. So integrating this, I get 3 natural log of x minus 3 plus 2 natural log of x plus 1 plus c, and that's my answer. Okay? Alrighty, let's do another problem. Oh, look, it's already done for us. So let's erase this and do it again, because I've told you I've done this problem several times. Okay, so now we're going to start by factoring. Yeah, that's right, factoring. So we pull out an x. We rewrite this as x minus 12 over x times x minus 4, and that's going to equal to a over x plus b over x minus 4. A couple of things I need to stop and remind you of. One is that it doesn't matter which one we call A and which one we call B. It all comes down the wash. Secondly, we can only do this if both of our factors are linear and non-repeating. So in other words, if this had been x minus 4 squared, I could not use this method. In Calculus 2, we only deal with, we can only do this when the factors are linear and non-repeating. You'll learn how to deal with other things in Calc 3. Okay? So we factored, we found our equivalent expression. We need to find A and B, so let's multiply by the least common denominator. As you should have seen by now, the x times x minus 4 cancels, and I'm left with x equals 12. When I multiply this by the least common denominator, I get A times x minus 4 plus bx. So once again, I'm looking for a value of x that will zero this out. So we can already see that if I use x equals 4, and I replace 4 here, I get 4 minus 12 is negative 8, and that's equal to 4b. So b is equal to negative 2. Now, what will zero this out is x equals 0. So putting 0 in for x, I now get negative 12 is equal to, putting in 0, negative 4a, which of course gives us a is equal to 3. So now rewriting this, I get the integral of a, which is 3 over x, minus, because this is subtraction sign, because it's negative, sorry, x minus 4. And once again, I integrate this and get 3 natural log of x minus 2 natural log of x minus 4. Now, I don't care if you write it like this or if you write it like this. If it's multiple choice, it may be written like this, so you just need to be able to go back and forth. If it's a quiz, you may leave it like this. Okay, I'm going to give you a second. Why don't you go ahead and pause this and try this problem, and you can see the answer is already listed here. So go ahead and pause this and try it and see if you get the same answer that I have. Hopefully you'll get the same answer. Okay, now, this problem is not in your notes. What I'm going to need you to do is to the last column, the first column, last row, that problem is repeated. So if you can erase that problem or mark it out and replace it with this problem, that would be amazing. Okay? So and I chose this problem because a lot of times kids struggle on this one because you have to use your substitution and they forget to use your substitution. Okay? So what we're going to do is again factor this. So we get 2x and x. I think 3 is going to go here and positive 1 goes here. Let's see if that's right. That'll give me negative 6x plus 1x, negative 5x in the middle. Okay, so now that I've factored that, and that's a jacked up plus sign. Okay, so now that I've factored that, I'm going to find my equivalent expression. And that's going to equal to a over 2x plus 1 plus b over x minus 3. Okay, so now we multiply by the least common denominator. We get 7 is equal to a times x minus 3 plus b times 2x plus 1. To zero out the a, we're going to do x is equal to 3. So that gives me 7 is equal to 2 times 3 is 6 plus 1, 7b. So b is equal to 1. To zero out the b, I'm going to make x equal to negative 1/2. And if I solve that, I get 7 is equal to a times negative 1/2 minus 3 can be written as 6/2. So this is 7 is equal to negative 7/2 a. Multiplying by the reciprocal, I get a is equal to negative 2. Okay, now here's where a lot of students make their mistake, is in this part. This becomes the integral of a, which is negative 2, so I'm going to do negative 2 over 2x plus 1 plus 1 over x minus 3. Now, All along, we've been using U substitution. We just haven't called it that because it hasn't made a difference. But if I let u equal to x minus 3 here, then du is simply equal to dx. So it really didn't matter. I could just do a direct replacement. However, when I let u equal to 2x plus 1, what do I now get when I have du? Du is equal to 2 dx. I don't have 2 dx in my problem, so I have to divide that by 2, so I get 1/2 du is equal to dx. So when I'm doing a direct substitution, I have negative 2, and this 1/2 has to come out, the integral of du over u, which of course is just negative 1, the natural log of u, but what is u? U is 2x plus 1. Okay? And that's going to be plus the natural log of x minus 3 plus c. And you can see that that is the answer here, but where students make their mistake is forgetting to do U substitution here. Okay? Now, I'm going to go ahead and stop this video here, and there will be another video that will come up in a, wait a minute, I'm not stopping it. There are 2 examples. Here are the 2 examples, and here are the answers to those 2 examples. So if you want to take a moment and pause the video and work on those 2 examples, that would be amazing because you need to finish your notes. And then once you finish that, then go to the second video.